Hey, good morning, everybody. This is Mr. Ainsworth here at Great Oak High School, and we're going to get into a review of solving systems, a review of all three methods, graphing, substitution, and elimination method here. So grab your review here in Canvas, and let's get started here. All right, we're in 2025 here at Great Oak High School. All right, now, so if you don't have this already in there, whoops, go to Canvas here. Notice that we're in Unit 4 on Systems here. Go into 4.4, Review Number 1 in Solving Systems, and grab your document right here. Just click on the hyperlink. Put it in a OneNote here, and let's begin. Or if you want on paper here, just go ahead and print it off. All right, let's do it. Okay, now the first system here is a very basic one. We're already in slope-intercept form, so let's just go over some basics here. So this is y equals mx plus b. It's called slope-intercept form. And it's called slope-intercept form because you can see the slope in the y-intercept given the equations here. So here in the first equation here, your slope is negative 1/3. And as you guys know, that's rise divided by run. So we're going to go down 1, right 3 from the y-intercept. And then see minus 1 right there. The y-intercept is negative 1. So we're going to start at negative 1 on the y-axis. Okay, now the vertical axis is the y-axis here. Notice it's labeled y. The horizontal axis is x. That's the x-axis here. So we're going to start at negative 1. And then from that point, if you put your pen there, all right, we're going to go down 1, right 3, because slope, all right, is equal to rise divided by run. That's one of the many definitions that we know about slope. Okay, so if you go down 1, right 3, all right, and repeat that, down 1, right 3, you're off the grid. So let's reverse that slope. Let's go up 1, left 3, right here, and draw your line. Okay, just give a little sketch right through here. There you go. And there's your first function here, y equals negative 1/3 x minus 1. Now the other one is a little bit different here. Your slope is negative 4/3, right, which means we just go down 4, right 3. Negative 4 means down 4, as opposed to positive up, negative down. And if the denominator here is 3, it's positive, so you go to the right versus the left. Okay, and the y-intercept here, whoops, the y-intercept is 2, so I'm going to start at 2 on the y-axis. Okay, and then you go down 4, 1, 2, 3, 4, right 3, 1, 2. Oh my God, we landed right there. And again, I already see the solution. So where the two lines meet is the solution for the system. So the blue line there is y is equal to negative 4/3 x plus 2. And my solution, okay, is right here. Okay, the solution is where the intersection is where they intersect. Intersection is the point they have in common, right? So the intersection is called the solution, is always x comma y right here. And if you go right 3 down 2, okay, so right 3 down 2, 3 negative 2, you got your solution. It's where they intersect. Okay, and that's the solution for any system, no matter how many equations it has. And later on in Algebra 2 or higher mathematics, you'll be solving systems of 3 equations, okay, with 3 unknowns. On the, look at that, not the coordinate plane, all right, but the 3-dimensional plane. So you'll have x, y, and z axes, but that's later on. All right, so let's stay focused. Now, when it comes to equations in standard form here, which is number 2 here, standard, oops, let me go to red here. If you're given equations in standard form, okay, what you have to do is convert them to slope-intercept form. That's one slope-intercept form, which means you have to isolate y. Okay, so I'm going to write that down here. Isolate y. What does that mean? Well, it means get y by itself, right? Get it into slope-intercept form. Y equals m times x plus b, which we've been practicing since the beginning of school. All right, so I'm going to do that first. So I'm going to take my first equation over here. It says x plus y equals negative 2, and I'm going to add the opposite of x. Right here, you always add the opposite of x first, all right, to isolate y, and we have y is equal to negative x minus 2, and then you can graph it from there. So let's do that. So the slope here is negative 1. So negative x is a negative 1x. You can put a negative 1 there if you want. So the slope's -1, or you can say -1/1, so you can see the rise and run. And the y-intercept is -2, because I see a -2 there. So you start at you start at -2 here, all right, down there at -2 on the y-axis, and then you go down one, right one, plot a point, down one, right one, you get a negative slope. But negative slopes always go to the lower right, right? Positive slopes go to the upper right. Okay, so I'm going to reverse it. I'm going to go up one, left one, up one, left one. That's what I teach everybody in class. Just repeat it, and you can see the line form. Okay, and when you see the line form, that's good because you're trying to find the intersection of these two lines, right? That's the solution to the system, which is the point they have in common. All right, so this is the first equation here. Y is equal to -x minus 2, or you could write it as x plus y equals -2 as well. It's the first one. Now the second one, let's take it over here. I'm going to rewrite it. You got 6x plus y is equal to 3. I'm going to add the opposite of x on both sides. And I have y is equal to -6x plus 3. So I know that my slope is -6, which is -6/1. So I can see my slope rise over run. I know my y-intercept is 3, so I got to start at 3 on the y-axis, right there at 3. And then I go down 6, right 1, down 6, right 1. So I count down 6, 1, 2, 3, 4, 5, 6. Excuse me. Yeah, okay. Holy cow, let me see. Is that correct? Let me see. Just checking things here. So, yeah, that's right. I wrote it correctly. So 1, 2, 3, 4, 5, 6. All right, right 1. Oh, there it is right here. So down 6, right 1 is very steep. So let's see if I can sketch this okay here. Very steep right here. Okay, and that one right there is your first equation here. I'm going to write it in the original form as 6x plus y is equal to 3. Okay, or you can label it -6x plus 3, however you like it. All right, and notice that our solution right there is 1 right, down 3, so it's 1 comma -3. There's your soluzione, all right, where they intersect. Okay, so any system, if you graph it, all right, the solution is found by looking at the intersection. All right, and there you go. There's your two basic problems there. One, fairly straightforward. Number one, it's already in slope-intercept form. Second one, you have to get it in slope-intercept form, graph, and find the intersection. All right, next technique called the substitution method. If you don't graph, you can solve it algebraically, and sometimes you have to because the solution is not always on the grid lines, guys. And if it's between the grid lines, guess what? It's fractional. And if it's fractional, you're not going to be able to find the exact solution by graphing. So you need an algebraic technique, either the substitution method or, as we talked about before, elimination method. Okay, so let's start talking about the substitution method first. I did number 3 already in class, so I'm going to pick a few in a variety here. I'm not going to do all of them. All you need is you just need a few of them here just to get the right idea. All right, so if you need some help, let's take a look at number 4. Okay, now y is already isolated right here, and it's equal to 6x plus 9. So what I want to do is take what y is equal to, all right, which is 6x plus 9, and substitute it in. Sub into the second equation, okay, the other or the second equation. That's why they call it the substitution method. Okay, so here we go. I see 8x here plus 6 times whatever y is equal to 10. So notice what I'm doing here. I'm getting set up for the substitution method here. Whatever y is equal to, you substitute it in. All right, so we're going to substitute it in. I know y is equal to 6x plus 9. And now what I want to do is I want to distribute through the 6. Okay, the distribute means multiply here. All right, so let's do that. So from left to right, I've got 8x first plus what? Well, I see 6 times 6x, 36x. 6 times 9, and that's 54, and that's equal to 10. When I add like terms right here, like terms are terms with obviously the same variable involved, and 8x plus 36x. So let me see, 8x's plus 36 more. You're in the 40s. Sounds like 44x here, plus 54 is equal to 10. All right, add the opposite. All right, the opposite of 54 is a negative 54. What do we get? We get 44x here. These opposites cancel to 0. 10 minus 54 is negative 44. All right, and then you just ask yourself, 44 times one number equals negative 44, and the obvious answer is negative 1 right through here. So x has to be negative 1. And then you got to solve for y. So let's go over here. I'm going to bring the other equation over here. The first one here, I know y is equal to 6x plus 9. And so what we want to do is we want to take our value for x here, and you want to substitute it in. And again, you're going to be using the substitution twice, right? Once you know x, you got to find y, because again, solutions are ordered pairs. And then what we have here is y is equal to 6 times negative 1, and then plus 9 more. So 6 times negative 1 is negative 6, plus 9. 6 minus negative 6 plus 9, or 9 minus 6 is 3. So my solution here for this system is negative 1 comma 3. Remember, it's always x and then y. Okay, all ordered pairs are x comma y's. All right, and there we go. Okay, now if the solution, or if one of the equations here is not doesn't have a variable isolated, like in number 3 and 4, well, then you got to do some work. Okay, you got to do an extra step. So let's go through number 6. We did this in class as well, but I'm just going to go through it here in case you need a little bit more help here. Let's do number 6. Sorry about the background noise here. That's my little Frenchie Romeo there. Okay, now number 6 here, we got to get a variable isolated. And so you got to pick a variable here that is easy to isolate. So to isolate 5x, or x, the x variable in the first equation, well, that's going to take some work. I have to subtract y and divide by 5, and it's going to create fractions. So that's not very good. Y is fairly easy to isolate because all you do is add the opposite there, negative 5x. I'm going to choose to isolate y. Okay. So let's write that down. So isolate y first. Okay, so I'm going to take the equation over here. So 5x plus y is equal to 9. I'm going to add the opposite. And I've got y is equal to negative 5x plus 9. And if you wrote this as 9 minus 5x, that's cool too. That's the same thing. Okay. Now what we want to do is, again, substitute what this is, okay, into the other equation, the second one. All right, so let's get that set up. So I see negative 2x here. I'm looking at the second equation right now, minus 6 times whatever y is, and that's got to be equal to 2. So again, whatever y is, all right, you substitute that in. So let me highlight what I'm talking about here. So you substitute whatever y is equal to, and in this case, it's negative 5x plus 9, right, into the other equation. All right, so let's substitute that in, negative 5x plus 9. Now I'll go back to distributing here. So we're going to distribute through the negative 6, and be careful here. We're going to distribute through a negative number, which is going to change the signs. So from left to right, I've got negative 2x first. Negative 6 times negative 5x is positive 30x here. Negative 6 times positive 9 is negative 54, and that's equal to 2. So you got to distribute, all right? Distribute means multiply. Multiply. Okay, and then you have to add your like terms, okay? Negative 2 plus 30 is 28, or 30 minus 2 is 28. So I have 28x here, minus 54 equals 2. Add the opposite. So we have 28, oops. Just wrote that here. 28x is equal to 56. And guess what? 2 times 28 is 56. So that ends up nicely here. Or you can divide by 28, however you want to think about it. All right. And x is equal to 2. All right. Now we need to find the solution to the system, which means I need to substitute back in to find y. So this just goes up here. All right. Substitute in. And what do we have? We have y is equal to negative 5 times x, which is 2, plus 9 more. So y is equal to negative 10 plus 9, which is a negative number because you have more negative, and you get negative 1 here. Okay, so my solution here, again, is always x comma y. As I always say here, x comma y. And so my solution is 2 comma negative 1. There we go. So they call this the substitution method for obvious reasons here, guys. They substitute. And again, these are videos here, so when you guys watch this, if you guys need help, more help at home, and you're watching the video here, let me just give you a suggestion. You should be pausing, playing, rewind it, listen to it a few times, and then afterwards, after you go through the whole solution here, this is you've got OneNote. Go off to the side and write the equation down again and do it on your own, right? Practice what you learn and test yourself. See if you can actually do it on your own without my help. Okay, so use your videos wisely because copying does not help you with anything. Okay, so go through it, test your understanding by actually doing it on your own, and develop some confidence. Okay. All right. So in the beginning, we talked about the graphing method. Then we talked about the substitution method here. Now let's go to elimination method. All right, now elimination method, what we want to do, and let's put this in red here, is we want to eliminate a variable, and the key to that is to find or create opposites, as I've said multiple times in class here. So find or create, okay, what are called opposites. So let's talk about that. What does it mean by opposites? Okay, so let's take a look at the first system here in number 8. Now, if you look at the x variables here, the x variables in both equations here, 5x and negative 7x, and those are not opposites, okay? Not opposites. However, I see 3y and negative 3y. Those are opposites. So we're going to focus in on eliminating y first, okay? So eliminate y here by looking at the opposites. And I see 3y and I see negative 3y. And so if you add the equations here immediately, because they're already opposites, these are going to cancel out, and you're going to eliminate the y's. And then you're going to solve for x. So what do you get? Well, 5x plus negative 7x is negative 2x here, right? Plus 0, and that's going to be equal to negative 19 plus 23, which is just 4. So what you have here is a very simple equation. You have negative 2x equals 4. All right, and if you divide both sides by negative 2, you get x equals negative 2. All right, great. Now what we need to do is solve for y. So you substitute back in, you take this and you substitute back in, and you pick an equation and you use it. So I'm going to pick the first equation here. I'm just going to write it down again. 5x plus 3y is equal to negative 19. And what I want to do is take negative 2 here because it's the next value and substitute it in the equation here. And you can use either equation, it doesn't matter. I chose the first one just for funsies, and then you just go for it, right? So 5 times x, which is negative 2, plus 3y is equal to negative 19. All right, that gives us negative 10 plus 3y equals negative 19. Add the opposite. You get 3y is equal to negative 9. 3 times negative 3 is negative 9, so y is negative 3. And there we go. I have my y value. So my solution on this one here, again, it's always x comma y. And so in this case, it's negative 2 comma negative 3. X is negative 2, or y is negative 3. That's the point they have in common. Okay, so we call this the elimination method because when you add the equations and you find or create opposites here, you eliminate a variable and then you find the other variable. That's where the name elimination comes from. Okay, now if you don't have opposites, which sometimes you don't have opposites, you got to create them. That's why I say find or create, because number 7, it's fairly straightforward. They give you opposites, but sometimes, like in number 8, you don't have opposites. So if you want to eliminate the x's, for example, so let's take a look at that. You want the opposite of 8x here on the first equation. Right now, negative x is not the opposite of 8x. But it's easy to get because if we multiply the first equation by 8, 8 right here, multiply both sides by 8. We get a new equation here. So what we're going to do is we're going to eliminate the x's here. Let me write that down. Eliminate the x's here by creating opposites. Okay, so what do we get? So 8 times negative x is negative 8x. 8 times negative 4y is a negative 32y. And then 8 times negative 7 is negative 56. All right, so this first equation becomes negative 8x minus 32y equals negative 56. And then the second one, well, you just rewrite it underneath it. And we're not going to mess with it because we're creating here, we're creating opposites. So we're going to add the equations now. And notice that right here, those are the opposites. Negative 8x plus 8x is 0. Boom. That's the reason why that we just eliminated the x's there. Negative 32 and a negative 4 is negative 36. Be careful there. A negative plus a negative is a bigger negative. And then negative 36 plus 20 is a negative number because you have more negative. And then 56 minus 20 is 36. So we get negative 36 here. And then, of course, then you just ask yourself, negative 36 times what number equals negative 36? And the answer has to be 1. All right, so I have my first coordinate out of the order pair in my solution. Now I got to find x. All right, so I'm going to rewrite my second equation down here. I'm going to choose to use it. It doesn't matter what equation to use. You're going to get the same result. I'm going to bring in the y value. I know y is 1. Okay, so the only thing I need to do is find x. So I've got 8x minus 4 times 1 equals 20. Again, we're substituting in 1 because I know what the y value is. Okay, and then you just simplify it. All right, 8x minus 4 equals 20. Then add the opposite. And I get 8x equals 24. And then 8 times 3 is 24, so x is 3. So my solution in this case is 3 comma 1, right? It's always x comma y. There we go. So now we're talking about the elimination method here. Our goal is to eliminate either variable first. It doesn't matter which. And if you don't have opposites, you got to create opposites. So sometimes you only have to multiply one equation by a number to get opposites. Sometimes you have to multiply both of them to create opposites. So let's take a look at number 10, okay? And then you can get creative on number 9 on your own, but number 10, let's go for it here. So here, looking at the variables here, we can eliminate the x's or the y's, and let's suppose that we want to eliminate the x's. Let's just pick one, okay? Sometimes one is easier than the other, but if you don't know, just make a decision. Here, let's eliminate the x's as our choice. To do that, I need the LCM of 6 and 9. So LCM, least common multiple, okay, of 6 and 9, which is 27. You could use 54. 9 times 6 is 54. Excuse me, not 27. What am I thinking? 18. Okay, so both are multiples of 18. I mean, factors of 18. God, Aynesworth, come on. So 9 times 2 is 18, 6 times 3 is 18, so the least common multiple of 6 and 9 is 18. Okay, you can simply multiply the first equation by 2, all right? I can multiply the second equation by 3, and I get 2 new equations. Okay, so let's see what we got. All right, so the first equation here, 2 times 9x is 18x. 2 times 10y is 20y. Basically, we're just doubling it, guys. That's all you're doing. 2 times 19 is 38. So you just double everything on the first equation, and then you triple everything on the second equation. Okay? Actually, we should multiply it by negative 3 because we want an opposite here. So let me change that. I'm going to make this negative 3 here. And then on the right-hand side, you got to be careful. I got to use parentheses here to make it look like multiplication. You want opposites, so we're going to multiply by negative 3 because we want one to be 18, one to be negative 18 in terms of the x variable. I'm talking about the coefficients there. So negative 3 times 6x is negative 18x. Negative 3 times 9y is a negative 27y. And then negative 3 times 15 is negative 45. There we go. And now we add the equations or combine the equations. And then again, the opposites obviously add to 0 here. The x's are eliminated. That's what we say. Again, this is elimination method right now. And then negative 20y minus 27 is a negative number. So negative 7y here. And then again, 38 plus negative 45, that's got to be negative. 45 minus 38, and guess what? That's 7. So y here is equal to 1. Negative 7 times 1 is negative 7. And then you pick an equation, and you got 4 to choose from to find x. So I'm going to just pick the first one over here. I'm just going to rewrite it so I can see it better. So 9x plus 10y is equal to 19. And then I take my y value here, okay, and I substitute it in. Or you can do double elimination. I talked about that in class 2. So you can either substitute the y value in and solve for x, or you can do double elimination. It's totally up to you. So now we have 9x plus 10 times 1. 10 times 1 equals 19. That gives us 9x plus 10 equals 19. Add the opposite. You get 9x equals 9, and 9 times 1 is 9, so x is 1. So now I have my x value, and now my solution, all right, which is always x comma y. In this case is 1 comma 1. And there we go. So the rest you can do on your own. That is right there a sample of all 3 methods for you to help you guys at home. All right, and this is Mr. Ainsworth here. Again, this is a video, so use it wisely here. And then obviously practice on your own. You have an iPad. And if not, just print another copy off and then practice on your own. Or just get a blank piece of paper and just rewrite the system and practice. I mean, the point is like you got to learn it, but then you got to do it on your own. So practice effectively. I'll see you in class. You guys take care. Make yourself proud. I'll see you soon.